Welcome back from the Christmas break. This is our first lesson of the spring semester. This will be lesson 6-1. Chapter 6 is focusing mostly on exponent rules, polynomial operations, and factoring, all of which are extremely important in order to do everything that we are going to need to do with quadratics in the next couple chapters. So today's going to be pretty easy because you've done most, if not all of this before back in August. We're going to do polynomial operations. So we're talking addition, subtraction, multiplication, and division. So addition and subtraction are basically collecting like terms. So if I look at this problem A, I look in this problem, are there any other x's to the first power? Seeing none, 5x goes in my answer. Okay, and I'm done with him. Are there any other y's? So I have negative 7y and 2y, which would make negative 5y. Okay, I just added them together. Negative 7 plus 2 is negative 5. We're done with those. Now I have x squareds. These can't combine with this because this has x to the 1 power. These are x to the 2 power. And remember, to be like terms, you have to be the same base, or basically what the x is, to the same power. So I have 2x squared and then subtract 5, which would give me negative 3x squared. This is my answer. Okay? And to write it properly, you put your highest power first. So this would be considered correct, but this would be considered proper, I guess. So 3x squared plus 5x minus 5y. Okay? You can also have a problem that looks like B, where I have this whole polynomial, a trinomial, because it has 1, 2, 3 terms, subtracted by another trinomial, 1, 2, 3 terms. So what I would do in this situation is I would go ahead and drop the parentheses from the first, x squared minus 5x plus 2. Now, this subtraction sign means I'm subtracting this whole polynomial. So the easiest way to go about it is to change the sign of everything in the parentheses behind it. So just like that. So we'll have minus 2x squared, oops, got my squared, plus 3x plus 8. And then it works just like above. X squareds go together. 1 minus 2 is negative x squared, or negative 1x squared. Okay? Those are done. Negative 5x plus 3x is negative 2x. Got rid of those. And then 2 plus 8 is a positive 10. And so I have my combination. Pretty easy. Can you add the numbers, and can you pick things that are alike? Okay? Now, this is what some of the multiplication is new. We weren't quite to the stage where we needed to know a whole lot of multiplication. So what we did in August was like multiplied this x squared through the parentheses and distributed it. So x squared times 5x is 5x cubed, remember? And then I would do negative 3x cubed, and then plus 2x squared. These I can combine, so it would be like 2x cubed plus 2x squared. Since these are not the same power, that is my answer. Now this next part is going to be a little bit crazy, but I have some tricks that will make it a little easier for you. We'll simplify it. Back in the old days, you would take x and multiply it by x, and then multiply it by 3, and then take negative 5, multiply it by x, and multiply it by 3. In my past experience, that's been kind of tough to keep up with. So I've taken a little bit of biology and made it work for math. So if you were in biology, you'll recognize this as a Punnett square. And I'm going to write x minus 5. The square is x. The square is negative 5. Everybody sees how I did that. And then this side will be x plus 3. Okay? So now x times x, well, that's easy. That's x squared. X times negative 5, that's negative 5x. 3 times x, well, that's 3x. 3 times negative 5 is negative 15. Now, if you are diagonal in this direction from each other, you are like terms. So my answer to this problem would be x squared minus 2x, because negative 5x minus 3, or plus 3x is negative 2x, and then subtract the 15. There's my answer. And we're going to practice with this a little bit today, or we did in class, and this is just kind of a video for your reference. Okay, division, which is mostly new. We kept it pretty low-key in August because y'all were still new at algebra. Okay, anytime I take a like base, so both of these have a base of 6, and divide them, what I really need to do is subtract their exponents. So 11 minus 5 is 6. So if I simplified that, that would be 6 to the 6th power. Now I took a little bit of a step and made sure that we remembered some of the exponent rules. Here, they all have the same base. The top two are multiplied. So if I subtract when I divide a monomial, then I can add if I multiply, right? So I have 9 to the 7th power divided by 9 to the 2nd power. Well, that's, if I follow the same rules as above, this is like 9 to the 7 minus 2 power, which would then mean this would be 9 to the 5th power. Now this next one is a little interesting. I can rewrite this as y to the 5th divided by y to the 8th. Okay? So I'm going to take y to the 5th minus 8. Well, 5 minus 8 is y to the negative 3. Okay? I'm going to teach you how to simplify this later on this week. Right now, just know that it's y to the negative 3, because 5 minus 8 is negative 3. Okay? So here's a summary of important rules that you need to remember. We discussed them in August. I'm reminding you of them now. And most of these rules will appear on your EOC formula chart. So, to multiply powers having the same base, you add the exponents. So if I'm multiplying two things that have the same base, I add their exponents. So an example down here, if I have 5 to the 6th power times 5 to the 3rd power, that's the same thing as saying 5 to the 9th power. To find a power of a power, you multiply the exponents. So if I take any number and raise it to a number and raise that whole thing to another number, I multiply the two exponent numbers. So if I have like 3 to the 4th squared, I would have 3 to the 8th, because 4 times 2 is 8. Alright, so let's try one quick example. I'm going to check my time real quick. I'm doing okay? Okay, so I've got a power of a power here, and I've got two things multiplied. Okay, well the 2 doesn't really play nice with x cubed. So they're two separate things. So what is 2 squared? Okay, and then I have times x cubed squared times x to the 4th. I know that doesn't quite look better yet, but it's getting there, I promise. 2 squared is 4. X cubed to the 2nd power, well, let's see, we're raising a power to a power, so that must mean I'm multiplying. So I'm going to say, okay, well 3 times 2 is 6, and then we're going to multiply that by x to the 4th. Ooh, here's some like bases. I'm multiplying them, so that means that I'm going to add their exponents. So this would be 4x to the 10th power, and that's your answer. To divide powers having the same base, you subtract, and we kind of covered that just a minute ago. So here's kind of an all-in-one inclusive ordeal. We got multiplying, we got dividing, we got raising to a power, we got the whole works. So I'm going to go ahead and take care of the numbers. So I'm going to have 4 cubed times x squared cubed. That's all over 5 cubed times y cubed. Okay? I'm going to erase this to get it out of our way. And so whatever 4 cubed is, which is 64, I believe, 16 times 4, yeah, that would make sense. And then I have x to the 6th power, because 2 raised to the 3rd power, those multiplied is 6. All of that is over 125 y cubed. Well, aside from maybe simplifying these numbers, that's all that there is to that. There's actually no division taking place in this problem. Okay? And that'll end this video.